In D2L, I have now posted the elusive Wireshark lab. So this is effectively a, what would you say, a PCAP scavenger hunt. So there's another capture file in there. It just now occurred to me that I called this capture and I have another file in D2L called capture. They are different. So please don't try to do the lab with the wrong PCAP file. It'll be really hard if you do. Make sure you grab the one out of the Dropbox. And I actually think I did probably put in like even a little helper like, I'll give you the checksum or something like that of this. Oh, I just told you the total number of packets. That's what it was. So 16,133 packets inside of this network capture. So if you go to statistics and capture file properties and make sure you have the correct number inside of there, that will make sure you got the right one. So, anywho, there are, kind of like with our Splunk scavenger hunt, we have 10 questions again. So some of them are things that you can answer just inside of the PCAP file by finding things. Other questions will require you to perhaps do a little outside research on your own, but that is the objective here. So there's many IP addresses inside of here. There's pretty much one primary client doing all the requesting, so that's that question's asking. I'm just going to go through this, so inevitably when I get the questions, I've given everyone a heads up. So what is the operating system of the client? So once you figure out the local IP that's doing most of the talking, then you get to figure out what the OS of that system is. There is connections to FTP in there. So what's the username and password they used? Why is this easy to find? Because FTP is a plain text protocol, like it's not encrypted in any way. For future reference, for when some of you go out to work someday, you'll probably find someone using an FTP server. Maybe for important stuff, maybe not. Maybe for stupid things. If it's for stupid things, whatever. What's a good solution to FTP that's not encrypted? That's going hardcore, but you could do SCP. Well, you could do like SSH file transfers, but we're thinking like something that you can train a user to do. I probably wouldn't, like SCP is what I usually use, but I'm not going to train a user to do that. Because, well, I guess you could grab WinSCP, and that's not that bad, now that I think about it, but actually SCPing a file, yeah. Yeah, I think so. Ah, I'm out of date. Crisis. Oh, no, my bad. Well, so that's the cool thing with FileZilla is it does do FTP, but it does implement other protocols. So what it does is, what is the thing FileZilla does differently? Because it can just be a normal FTP server.
It was just a pretty FTP. Yeah.
Oh, it does do that, yeah. The other thing that FileZilla will do is it will wrap it over a TLS tunnel. So what is a TLS tunnel? The next stage of the game we're moving into is VPN goodness, so this will come up. You use a lot of TLS tunnels in your day. No one knows what TLS is? Yeah. Hopefully when you're browsing the internet, like logging into your bank or something stupid like that, you're using HTTPS. Usually we would say there's a different buzzword we'd use. That's another 3-letter acronym for when you're doing HTTPS. What's that? You just say SSL, right? Like, is it an SSL encrypted? And that's like still the norm of what we say, but do we really want it to be SSL? No, SSL is super old and super broken. Super bad deal if that's actually what you're using. So normally when someone says, well, it's SSL, we assume it's really TLS because TLS works. Well, that's just how it works. It just works for other people to decrypt your data really well too. So what FileZilla does is implements secure FTP, which basically says we're issuing a certificate. What the FileZilla client and server do is actually negotiate a TLS tunnel, so it's encrypted. Then it sends all the FTP data through that tunnel. So it's sending unencrypted data through an encrypted tunnel, so it's okay. It's actually no different than what HTTPS is doing. It's just making a TLS tunnel and then just sending HTTP traffic through it. So there's that. So remember, if you need an FTP server for something, FileZilla is pretty sweet. And unfortunately, the only downside to FileZilla is the FileZilla server only runs on what operating system? Windows, yeah. So there's that. But the client runs on like everything. So the FileZilla client you can download for any OS, even like mobile devices. So it's pretty neat. Anyway, a little tour away there. So there is a JPEG that has been transferred over FTP. If you notice inside of Wireshark, what was the thing you could do to get files out? So that would let you actually look at the text of the, unless you actually know the real answer to the FTP question. But yeah, if you go File, Export Objects, you can export things. But FTP is not in this list, right? So you get to go on an adventure, and it's not that hard. I just want to force you to go look up something for this process. So go figure out how you can find data inside of an FTP packet stream and export the actual data. So when you're done, there are two different JPEGs that were transferred back and forth, so you can actually export the JPEG out of the FTP stream. There's an error browsing a website, so what did they do? And then this is probably a trickier one. So the user visited 3 different websites, but what's the problem with just tracking down like visiting 3 websites? Do you really ever just visit a website? No. Now when you load it, you load a website and then your browser then loads everything on the website, which is coming from all different locations. So what's the trick to figure out which ones users visited versus which ones browsers are loading? How fast can a user browse to websites, usually? Yeah, like I as a user I can flip through tabs pretty quick, but when I go to DSU's homepage and DSU's loading all these images and a YouTube video and all that stuff, the browser's doing it faster typically than I can do. So there's that. We've got a DNS request. So what was the record they're requesting? Find request going out to. Guess that's a link inside of there, so don't click on that. Well, it's not going to do anything bad to you. To a particular domain, figure out what that's for and what's going on, what's the hardware involved, and then there's a particular HTTP file transferred. What's it doing? Why? Why do you care? All that good stuff. So, yeah, that is our Wireshark lab. So, in the end, the idea would be if you cannot come up with what you think is the actual official answer, but you're like, I came up with something, the idea behind the scavenger hunt is to like, why do you think what you found is the right answer, even if you're like uncertain or something like that. So feel free to go about it that way. No questions on Wireshark Lab? Nothing? Okay. There is one other batch of tools that we're going to load. So, like with Kali, like you could go install Metasploit on anything, right? Or pull down whatever package that you love to use inside of Kali. You can install that on any, for sure, any Linux operating system. maybe even Windows if you want to go down a real adventure. But we always just download and install Kali anyway, right? For the most part, I assume no one's building custom like Tiger Box kind of things. So there's a lot of tools for analyzing and tinkering around with traffic that are all stored inside of a distro called CsecurityOnion. So that's what we're going to play with for today. So we'll talk about what it is, and I'll actually just start an installer running so that I'm guessing most people have installed Linux and clicked the boxes, but just in case, so that everyone's been able to see it before. A couple places you can go grab it. You can go to securityonion.net if you're on campus. If you go to share.ilab.dsu.edu, because I love extended domain names like this. So if you go there and go to ISOs, there is a CecurityOnion ISO that you can download directly off of a share that's ran here on campus. Or you can go out to the internet and download it from GitHub. I don't care which one you downloaded. It doesn't make a bit of difference to me. The idea is theoretically downloading it off campus will be a little bit faster than online. That being said, what's going to happen is if you all go download it, you'll thrash the one server that it's living on because it's not load balanced. So that might slow down. But either way, once you have that downloaded, or here's my other pep talk. If you do not want to run a virtual machine on your computer, and this is very abnormal for me, right? Just run the VM on your computer, because I've run everything in the iLab. If you don't want to do that, that's fine. You can go to projects and log in with your DSU account and spin up a VM there. And the ISO already exists inside of the lab, so you can just insert it from there. So to do that, you'd use this little new button. Call it something, because these names are awesome. When I see VApp_username and then an arbitrary number. So when you go to add a virtual machine, just say new. And it's a Linux VM. And it's going to be based on Ubuntu. And do yourself a favor and give it more than a gig of RAM. But don't give it like a stupid amount of RAM, because that's going to be annoying when I go and look at logs and have alerts saying, this VM's using a half a terabyte. Then that'll irritate me. So please don't do that. Not that that's ever happened. The other fun one is when someone's like, hey, I'm going to mine Bitcoins in a VM with a CPU. That's also another one I really appreciate. Because the more the way the tiering of resources works, if there's CPU time available, it'll just give it to you. So that I actually don't care so much about. The actual mining of Bitcoins with a CPU is such a juvenile thing to do. Because are you going to do anything like mining Bitcoins with the VMs? No, because the complexity of the Bitcoin chains are so vast now that a very, very fastest Intel Xeon processor is never going to mine you a Bitcoin.
What if you make a lot of VMs? You use the whole iLab.
If you use the whole iLab and all of the processors, there's probably, when I count cores, there's probably about 500 or so Xeon cores, which is a lot of cores for processors, right? Because every server has dual socket, and those sockets are either quad or hex core. Plus, technically, there's hyperthreading, but that's not real. That's fake processor math. But either way, 500 cores versus how many cores are going to be in a GPU? Yeah, you're going to measure those in the thousands with one GPU. So one good graphics card will vastly exceed the iLab's Bitcoin mining potential. So it's almost like it wasn't built for mining Bitcoins, right? It's like a different purpose in mind for some reason. Then yeah, I'll just
With those grid cards to work.
put the what?
Those
Oh,
grid
the grid cards. Yeah, that is the one thing the iLab does have is a grid card, but that is not accessible to normal people, to users, just to me. So, there you go. If you come in search for security, what the grid card is a really funky graphics card when you look at it, because there is not oh, I just want a picture of the stupid thing. I don't want, oh, look at our marketing stuff, this is fun. I just want a picture of it. More marketing stuff. Well, we sort of get the picture here. So we have a grid K2, and you notice what is missing from the back of the card. Yeah, any output. So this is not meant for connecting to a monitor. This is just a graphics card to inject into virtual machines. So it's pretty cool how it works, and it's a fairly hardy graphics card as far as graphics cards are concerned. There's obviously more powerful GPUs out there than it, but with the more powerful GPUs that are out there, if you try to inject them into a virtual machine, you'll probably kernel panic them because the graphics card will just tip over on you. So there's that. Anyway, they are big and they put off a ton of heat. I can attest to that at least. So, yeah.
How much did that cost?
Back when we put it in, I think it was like 6,000 or 7,000. Yeah. I don't mine bitcoins with it. It's used for other stuff. So, yeah. There's actually some folks doing some like pseudo crypto hashing research, so they have access to it right now. I'm doing stuff because they basically didn't want to pay the power bill to run that on their own. I'm like, well, I'm already running the card, so you might as well use it. So they are actually doing hashing stuff within a VM. I presume anyway they're not mining bitcoins. Guess time will always tell, right? Research, yes. Anyway, I'm just gonna pretend like I'm making a VM here because I am gonna go through that, and then we'll talk about what CsecurityOnion is and the things that are inside of it. So we'll grab that, go. It's weird enough that it can't detect what it is, so we'll go Ubuntu 64-bit. And
So if you'll satisfy my curiosity, why they started the project?
what's that?
I said if you'll satisfy my curiosity, why they started the project using the iLab.
Oh, why? The same reason that like I could have given everyone a VM with Wireshark in it. The interface that the iLab has for doing stuff is not conducive to using a tool. That interface is really well for like, you have 6 VMs and you need to dink with the networking, and if you break it, whatever. Because that's really all, I mean, if you think about what we're doing inside of the VMs that are hosted in the iLab, you're not using them. You're typically just dinking with them. Whereas with this, like, this is a tool that you'd be using. Same reason with like for forensics, if you're in that class. You notice I do not host those VMs through the vCloud interface because you're using a tool and it would be annoying. So I just run them a different way. So, or I could have, I've done it in the past where I have given a capture file in a VM with Wireshark installed and given it out to everyone in the lab, and they're like, yeah, have fun. So, no, the idea is to not to make it a painful thing. There we go. Got a happy amount of memory.
Is this a 64-bit ISO?
Yes. So I'll get my little installer running. Oh. Well, and maybe I will revert back to using the iLabs. My disk is full. I have many things. Let's pause the recording. Anyway, so we got the temp files lead. Camtasia has never disappointed me by finishing a class period and saying, like, popping up with, like, oh, I actually gave up 4 minutes in. It's not done that, and it handles, if I full screen something, the resolution of my computer changes, it handles that. Whereas my other recording tools I've used will continue to record audio and a black screen, which doesn't do me a lot of good. So, back over here. Oh, yeah, let all of the VMs run. Here we are. So look at that. We're cooking with gas. So, yeah, we're going to go through, we talked about what this is, the hardware specs of it that we need, and just kind of go through the basic setup. So, it's our ideal tool for putting all of our traffic analysis kind of stuff together all in one spot. So the neat thing that CecurityOnion has is it's all free utilities, so that helps a lot. Then the other side of it is that it actually has a lot of like Wiresharky-esque tools that kind of can chunk apart data. So it integrates Bro and Squeal and Snort and whatnot all together. So we'll talk about what those are and what those do. So the two specific things, if you are, I've encountered this a few times before, this is a 64-bit edition VM. I don't think you can, you used to be able to choose between, yeah, it doesn't look like you can anymore. With the older version of it, you could actually choose between if you wanted 64 or 32-bit editions. Why do we want 64-bit edition? Or what's unique to that? The more bits, the better, obviously. So a 64-bit operating system can address more memory, more than 4 gigs of memory. That may or may not be a problem with whatever VM you're setting up. Like, I get that. But in a real-world type scenario where you're really deploying this, the idea is that in addition to CecurityOnion being good at, like, analyzing traffic and opening up Wireshark files and whatnot, we could actually take a monitor port on a switch and just pump it into this thing. So it actually will, now that I think about the way I set up the hardware, it's going to gripe at us because we only have one network interface. Once it's all said and done, we're going to have to go add a second network interface. It's going to demand that it has like a management interface for us to interact with and for it to go out to the internet. And then it's going to demand that it has a second Ethernet interface for capturing traffic. So what it's basically going to do with that second interface is put it in promiscuous mode and just capture, archive, index, and analyze every packet that comes into it. So that second interface is, if we were setting this up on a hardware computer, the one we would go plug into the monitor port on the switch. So doing all of that and capturing so much live traffic, you generally are going to set this up with lots and lots of memory, and so you need a 64-bit edition of the operating system. The other one is what's specific to Ubuntu 14.04 or 12.04. So it should be an LTS build. So LTS means what? Yeah, it's going to keep it supported for a long period of time. So the way you used to be able to get around the 64-bit problem is with PAE, or physical address extensions, which is something terrible to ever do. But what's like the ultimate computer science problem with 64-bit versus 32-bit operating systems and the amount of memory you can touch?
I know what you mean by that.
You think I know what I mean?
No, I don't think I understand what you mean by that question.
Oh, why do 32-bit operating systems have problems with lots of memory? Why can't they use like 12 gigs of RAM?
They just don't have the address space for it.
Yeah, so what kind of address space? What are we talking about? That you would have learned about in CSC438
I don't know.
Pointers. So pointers are your computer science way, your programmatic way of storing addresses of memory. Well, pointers, like being 32-bit or being able to address 32-bit address spaces just can only go so big. You just can't, like, once you hit that, like, 3.7 something gigath of RAM, there's just not, like, there's not another zip code. We've ended up with all 9s, and we need a, 6-digit zip code, and there's just 32-bit systems just can't handle a 6-digit zip code, right? So the physical address extension, if you see systems running that, that's when you kind of go, like, get the goosebumps, because you're like, oh no, you should have just installed 64-bit versions of Windows or Linux or whatever it is. So that's what's going on there. The other thing for the way CecurityOnion works is you will want lots and lots of disk space. So the idea of what this does, assuming it's running in a production, for what we're doing, it's going to be fine. You can use however little disk space you want. You're probably going to be fine. But if you're going to actually set this up, the idea is you would connect it and have it like we would connect this to DSU's WAN interface and sit and listen to all of the traffic coming in. So it's going to try to index and store all of that data. There's a couple mount points that it's going to store these in, or well, a couple directories. And you would ideally set those up as mount points. What's a mount point?
Where is the file system?
Yeah, so it's like in Windows when we have partitions, right? We have the C drive. And then if you add another disk, you'd have D or E or something, whatever you pick. Linux doesn't use drive lettering. It just uses mount points, or just uses effectively just folders. So what we could do is put like a really big hard drive, or probably RAID array, and mount it in that directory. That way when the directory gets full, we can expand it out a little bit further, and we don't have to worry about like reconfiguring the entire file system, what we got going on. So yeah, the sensor data directory is where it's going to actually store all of our like network traffic coming in. So if you go into those directories, once it's all set up, you're just going to find zillions of PCAP files that it has indexed. So storing all of your raw network traffic there. The other one is the MySQL directory. So what are we going to do with MySQL? Yeah, we're going to do all sorts of database-y stuff. For the sake of continuing with what's going on here, this should be pretty simple. We're not actually going to worry about doing mount points. We're just going to roll with it and just put everything on one root file system, which is tricky to change later on if you want to. But so this next part, where we're talking about time, it's very particular about getting the clock right. Why is that? Yeah, we're going to have, I think this is cute here, to where the layout's like this and all you can click is the back button. So if you scooch this over, pro tip, I have been installing Linux before, and I'm like, why is this just going in an endless loop? Realized I was clicking the back button. So scooch that over and hit continue. What's that?
I was like tab cycling through how many times I need to hit successfully go forward.
See, so this is why I show the Linux installer, so that you know how to get to the button that the VM is hiding.
Got it though.
Oh, you got it just through doing random tabbing?
Yeah.
We'll keep going there. Alright, I should be done now, and it's just going to do its thing. So, yeah, we have all these network devices all doing stuff. So, the thing that, when we're all said and done with CecurityOnion, we can do is not only index network traffic, but we can also start to take in syslog data. So, correlating all the timestamps so that they're actually, accurate to each other is going to be a really big deal. Because if you're trying to look for a firewall event along with a web server event, along with a particular set of packets, well, if you have to figure out, like, well, the firewall is offset by 2 minutes and the web server is off by some other arbitrary amount of time, that's going to be a thing. Similar, making fun of my own self. Have you ever noticed the clock in most of your virtual machines in the iLab is off by like a consistent 12 minutes? The iLab maintains its own time. It has an NTP server that actually has a hardware problem in the clock, so it keeps drifting back 12 minutes very consistently. And me just being me, like, well, we're just 12 minutes off because everything is exactly 12 minutes off. So I'm going with it. It's the same time. It's the same level of incorrect everywhere. So I just go with it. So that's a thing. What should we do with disk arrays if you have a bunch of disks inside of there? Whatever you want. Well, you probably configure some sort of RAID with it, right? So that if you lose a disk, you don't just lose all of your sensor data that you've collected. So that's going to be a thing. Usually, the way I like to configure stuff anyway is my operating system is running on different volumes than all of the data that I have going on. So that's going to be a thing. If you're doing a virtual server, you'd probably just have one large disk and you'd probably be fine, because with VMs, can you change the size of disks? One way you can. If you have a VM, you can make the disk bigger. You can't make it smaller. The hypervisor won't be able to reclaim space, but it can always add more. The catch with that is, and this is a maybe just general pro tip in life in general, if you're going to run stuff like this, it needs lots and lots of space inside of virtual machines. Some file systems have maximum sizes that you can hit, some disk types, and in the case of mini hypervisors, there's like the maximum size a particular virtual disk can be. So if you look at, like, if you were going to run this on ESX, your VM provider will tell you, like, here's the maximum size of a disk that I can make and stuff like that, which seems really virtual machine maximums. There we go. Well, and in 5.5, this is clearly not so much of an issue, because the virtual disk can be 62 terabytes, which I'm going to assume is not going to be a problem for most folks. But either way, check on those things, because you end up in a world of hurt. So making sure everything fits is going to be really, really important. So I guess I did already talk about this. So yeah, the MySQL directory, that database will eventually start to trim itself. It will purge out old, stale sensor data. But starting off, I would plan to at least be able to hold 100 gigs of MySQL data. Like, again, though, if you're setting this up like at your home network for something, obviously you're not going to have that much traffic. Unless you're doing like tons and tons of pirating or something like that, to where you are actually maxing out your bandwidth all the time, then the sensor data directory is going to get very full very quickly. So keep stuff like that in mind as well. So the other option, so once this is actually, I should check on how my install is actually going. Checking for things to remove, all this good stuff. So it's still thinking. So once we get it set up, I'm going to have to go and add another network interface into the box, because it's going to be unhappy about only having one network interface. But there's a couple different ways of setting up the way these are going to work. So if you take a network like DSU's, it's big, right? Both logically and just physically, like the geography of the Science Center all the way to Heston Hall to the production or the field house to the foundation. There's just geography involved. So one way we can do this in a relatively small, and it's obviously the easiest way to do it, is just one box to rule them all. So we have one central sensor taking in all the traffic, and that's great. But in the case of a big network, that's going to be hard, because we're going to start to miss certain pieces of traffic. That's going to be one thing. So like at DSU, I would probably put one of these CecurityOnion sensors in every building. So that way we could see like all of the inner switched traffic of East Hall's wired and wireless network. Why is that a problem? Why is it hard to see switched traffic if you just monitor things centrally? Yeah. So if we did all of our network monitoring from like a central, like the core firewall, when things are changing subnets, we're going to get a ton of information. But if we had two computers plugged into the wired network in this building, and one of them is infected and it's trying to attack other things on its subnet, we're never going to see that at the firewall because switches, right? The switch is never going to forward the packet over to the firewall. The switch is just going to be like, oh, your buddy that you're trying to kill is over here. I'll just let you connect. So switched networks make monitoring stuff really, really hard to do. So that's why we would need to put sensors like everywhere, which is, there we are, we're done. Which is why CecurityOnion is a really cheap way to do network monitoring stuff because it's for free, as opposed to going and buying something that's charging you per device or something like that. There's the other, or kind of the other method of doing this is setting up, instead of the centralized one, is all the servers will forward their data to a central spot, or you can have one just kind of like a great leader, sort of the dictator server, and all the data stays located on all the slaves around it, and when you're requesting data, it just goes and gets it for you. So if you have really, really big amounts of data, it's really hard to centralize it all because it's just going to take you so much bandwidth to ship everything back. So then I would just leave, like the East Hall network sensor just has its data, or the server room or the science center or whatever. They all just have their own pieces of data. And looks like that disconnected. So we will reboot and start up into CecurityOnion. So the next choice, when we actually get in here to set stuff up, is which IDS engine that you will get to use. So have we heard of Snort before? So Snort is like the kind of de facto intrusion detection engine that most places know of. The other one is Surcata. And I actually seriously have had people calling it Sriracha, and I'm like, that's not what it is. That's definitely, you're definitely doing word association with the wrong things here. There's some basic differences between Snort and Surcata. The general thing is Surcata's kind of like the new cool thing, whereas Snort's been like the oldie but a goodie. So there's generally, like, huge performance-wise, Surcata does better on computers with multiple CPU cores, as opposed to Snort. If it's a system with limited number of CPU cores available, it's going to be a little bit better. That's where Surcata is multi-threaded. So what's multi-threading mean? Yeah. So Surcata can be thinking about two things at the same time. So you have two cores because it's going to spin out multiple threads. Any of you that have done any sort of programming know that as soon as you start doing threading, there's a great deal of love that goes into tracking all of your threads, right? So, but it can process data typically a little bit faster if it's getting really, really slammed by stuff. So there's not really a downside to switching to Surcata other than people just kind of have their comfort level. So the other fun thing is, like, the Snort project is owned by Cisco now. They couldn't just leave a good thing be alone, or leave it alone, right? So they've bought it, and yeah. So anyway, there's another tool that's going to do a ton of a good way of analyzing network traffic for you called Bro, and it's literally BRO, Bro. So Bro takes all of your PCAP data and strips out metadata about it, basically. It can also strip out files really easily for you, and it makes it just easier to do analysis stuff. So if you think about, like, if we're trying to find malware inside of network traffic, Bro is really good at stripping out the networky stuff from it, and then just being like, okay, here's the data that was inside of this packet. Then at that point, we can just run antivirus against it or something like that. So Bro is going to ask us how many processes we want for all of this stuff. So basically it's asking how many threads do you want me to spin up for the IDS, which would be Surcata or Snort. Well, probably Surcata if you're doing multiple. And then how many Bro processes are you going to spin up? What number would you pick for these things? of how many processes to actually start spinning up. Did I make my username Kyle? Or is it DSU? That's going to be what does me in, is I don't remember what username I picked. Was it Kyle? Okay. So luckily I recorded it so I could go back, but... So the numbers we pick for these things are going to be based primarily upon how many cores we have. So if you have a system with 4 cores, you don't want to spin up like 8 threads of stuff because you're going to get contention among them. They're going to start to fight over the cores. So your kernel is going to have to start prioritizing, like, well, you get some time, and you get some time, and you get some time. So it'd be just better to match it. You're also going to still get your kernel, like when you open up the browser in the VM and it's going out and doing stuff, it's going to obviously interfere. But the primary idea is when this is just sitting and running in the background, really only these processes will be running. So try to just match the number of cores you have. Then we get, actually what I'm going to do right now is fix, fix this. We'll shut this off. I'm going to add my other network interface real quick. Just so that we don't get complained at. Sure. All right, now I'll start it back up. Which should come up pretty quick, and we'll talk about what else is going on inside of here. So, yep, keeps grabbing my mouse. When we go through and go through the actual setup, it's going to ask us which IDS rule sets we're going to use. So this is actually going out to SourceFire and pulling down the blessed community or the blessed snort rule definitions, whether you're using Staccato or snort. So it's going to do that, and then the reason why it's going to ask us which rule set is the way snort, basically network traffic signatures are released is they release everything for free, but they're delayed by, well, I don't know if I think. Delayed by 60 days or 30 days. So you get really, pretty decent network signatures for free, but you're missing anything new. So that's where they ask you for money. There's a couple differences. So one, you can register for free, and if I don't actually know what the intent is, but if you register for a free account, you get slightly newer rule definitions. It's just, I don't know if they're just into tracking people or something like that. Or you can pay them money, and then they will give you really up-to-date ones. So we'll have to configure credentials, all that good stuff. Whoops. Oh, now you're going to know my password. The last thing we'll tinker with is ELSA, and that'll be a little bit for us to get to ELSA. So ELSA is basically an open source version of Splunk. So Splunk being good at indexing logs, that's what ELSA does as well. ELSA stands for enterprise log and search, or search and log, or something like that. So it was basically written by a guy who was working for his company and was mad at how much they were paying Splunk. So he was like, screw this, I'm just going to write my own. So he did, and thus we have ELSA. So yes, we're going to configure this. It really wants, like I said, it's going to really want to configure your network interfaces for you. I would just let it do it so that it's got stuff set correctly. Otherwise, you can go into your Etsy interfaces and set this interface is in promiscuous mode and stuff like that on your own. But I would just let it do it. So, real world, what you do is pick this is the interface that I connect and assign an IP address onto to go out to the internet and stuff like that. It really wants it to be a static IP, which it should be if it's a server, but in this case, it's just going to be DHCP. And then you'll be able to check the box on all the other interfaces that you use for sniffing traffic, which is just going to be ETH1 for me. And yes, you make the changes. Very persistent about setting all this stuff. Well, of course, you have to reboot it now. Aha. And now, whatever type of hypervisor you're using is going to maybe freak out and say, hey, a virtual machine is trying to grab your physical network interface and access it in promiscuous mode, which on an average day should be a bit of an alarm to you. But what it will actually be able to do if it grabs your network interface is it should be able to see like the traffic generated by your host, like your actual host machine, because it's running the interface in promiscuous mode. So after we get rebooted again, we'll go back into setup, yes. And then you've already configured network interfaces, and you're like, yeah, I did, so skip it. So the idea behind, like when I go to set this up, is it's got like its quick and easy method, or it's like tweak each setting kind of method, and we'll just go with quick and easy. Even though I think it's funny that they call it like evaluation mode, as if you have to purchase it or something like that, but it's free. But either way, evaluation mode is going to be pretty simple for our setup. Then the next thing is we have to set up a couple usernames. So, which sounds dumb, but the services and stuff that we're going to be tinkering with maintain their own user accounts. So one of them, I'm just going to make a regular user account. And then, of course, the old standard password. And then, yes, apply it. And then I believe there's one service that no, maybe not. So I think there's one service that maybe requires an email address as the username, but I think they switched that around. There we go, now it's pulling in. So all of the like naming stuff around Snort deals with pigs. So if you notice it downloaded the rule signatures from pulled pork. You get it? And then the utility that we'll spend the most of our time with is going to be squeal, which, you know, pigs, they squeal. Then there's also squirt. That one's not as fun. So we'll get that up and going. It's doing Elsa stuff. And then we should be ready to go. And then we'll stop there. We're just talking about CsecurityOnion. There's only so much I can actually spend talking about just like, it's a Linux distro. But that's what it is. Does anybody have any questions on this or whatever? So, okay. My only other word of advice is you do need to have a, not like super new, but relatively new-ish processor in order to run 64-bit VMs. So if you have like an original Intel Core Duo or Core Quad processor, that will not support running 64-bit virtual machines. So then you will be stuck with, I think my dad was supposed to be meeting me today and must be at my house already because I keep getting notices that my door is locked and unlocked. So he must be coming and going. I don't know what he's doing. Anyway, so if you look at me as I keep looking down, like, your front door was unlocked. I'm like, oh. Anyway, yeah, so if you do have an older machine that can't do 64-bit, then you will have to run it in the iLab or something like that. So anyway. Yeah, so here we go. We'll get all of our fun info on stuff, services and whatnot. So, yeah. We will ultimately, I'm pretty sure anyway, not have class on Thursday. Well, no, we for sure won't. Because I will be on an airplane. And that will be challenging to have class then. So, we will pick up with our security monitoring stuff on Tuesday. So, we'll see y'all in a week.